Hello. So we have a problem of a particle sliding down a ramp, and then there's a ramp that is like curved upward, so the particle just like jumps up. And okay, let's read the question. So a particle starting from point A, which would be right here. That would be A. Well, actually, yeah, somewhere over there is A, at a height of h naught of 2.5 meters. And by the way, the numbers in red in the original problem are going to be different for you, so use your numbers instead of mine if you want to get it right. So just pointing that out. And then continuing, so it starts at a height of 2.5 meters, and this is projected down the curved runway. And upon leaving the runway at point B, and this should be B right here, at point B, the particle is traveling straight upward and reaches a height of 4.2 meters above the floor before falling back down. Ignoring the friction and air resistance, find the speed of the particle at point A. Alright, so how the heck do we do that? Well, it's called law of conservation of energy. So it says, so I guess what this diagram and what this the question is saying is that the particle A travels at this particle travels at some initial speed, and then it runs down like this and then goes up, and then the height of final is where its speed is 0, which means it's at the maximum point, at its maximum height. Okay, so what the heck does that mean? Well, when it's at the maximum height, its potential and all of the energy is converted into its potential energy, and which means anywhere between the highest point and the ground, the particle would have some sort of potential energy and a kinetic energy. But at the top there's only potential energy, and at the bottom there's only kinetic energy. So how do we write this? How do we write this out? Well, we're only interested in let's look at this differently, from a different perspective. So this is H final, and this is H naught, and this is H naught. So basically, what we want to do is, if H final is where you started, we want to find the speed, the kinetic energy at H naught. So what is the distance here? That's what we're trying to figure out. Well, I mean, that's what we're trying to figure out, the change in kinetic energy from here to here. So let's do that. So let's go ahead and do that. So we know that Ke plus Pe is equal to Ke plus Pe, right? Okay. Well, okay, so this side is going to be this side is going to be HF side, and this is going to be H naught side. H naught side. So what is our what is that H final? What is our kinetic energy H final? Well, it's 0 because it's not moving. What is its potential energy? Well, it's mg times H final, and that is equal to, well, what is our kinetic energy here? Well, it's mv squared over r, or I mean 2. R is mv squared over r is circular motion, the centripetal force formula, and we're not concerned about that right now. And potential energy at A is H naught, right? It's just H naught. The height is H naught at A, so mg times H naught. And do we have H naught? Yeah, we have this right here. Do we have H final? Yes, we do. We have H final here. Okay, so what do we do now? We just solve for v squared now. Let's use simple algebra to solve for v squared. So I'm going to use one color this time. So mg, I'm just going to rearrange the equations so that we just solve for v. But before we do that, we know that the mass cancels out. Okay, so gh final minus gh naught. So I subtracted gh naught from each side. So I got this. Is equal to v squared over 2. And further, with further simplification, we get 2 times gh final minus gh naught. Actually, look at this. G can be factored out too, so we can actually write this as 2g times h final minus h naught is equal to v squared. Now, if we just take a square root of it, it just equals to v. So let's go ahead and plug that into our calculator. Okay, so this is the square root of 2 times gravity, 9.8, times h final minus h naught, and our h final is 4.2. So 4.2 minus h naught is 2.5, and I think that's it, right? So square root of 2 times 9.8 times h final is 4.2 minus h naught, which is 2.5. So all of that square rooted is equal to v. So let's press enter. I forgot the last parentheses. Press enter, and we get 5.772. So our velocity or speed is 5.772. And there's a difference between velocity and speed, but and speed is a magnitude of the velocity, but right now we're just concerned about the speed. So that is how you get the answer for this problem.